In this section, we're going to introduce decimals to you. Now, you already know the names for the columns to the left of the decimals, the ones column or units column, the tens column, and the hundreds column. Now, there are matching columns on the right-hand side, except that there is no ones position. It begins with the tenths position, followed by the hundredths column, the thousandths column, and the 10,000ths column after that. Now, let's talk a little bit about rounding. The rules are pretty much the same, except for how we insert zeros and do the rounding off to the right of the decimal. Let's say we are rounding to the nearest tenth. We are still going to identify the digit that is in the tenths column, and then look at the position after it to make our decision. And since 8 falls in the 5 through 9 category, we will be rounding up. And so this 1 will become a 2, but we do not replace the remaining values with zeros. Instead, we just finish this with a 0.2, 745.2, or we can pronounce that as 752 and 2 tenths. Notice how I'm pronouncing the tenths there. Let's say now that we want to round to the nearest hundredth. In this case, the 8 falls in the hundredths column, and the 3 just after it is in that 0 through 4 category, which tells us to round down. Now, when we round down to the right of the decimal, the 8 stays as it is, so we will have 0.18 after the decimal, and then we will have no digits after that. So this rounds to 745.18, or 745 and 18 hundredths. Now let's talk about how we pronounce decimals. Let's say we have 45.3. The decimal is going to be pronounced as the word and since the 3 falls in the tenths column, we will pronounce that as 45 and 3 tenths. If this is now followed by a 7, that 7 falls in the hundredths column, and we would pronounce this as 45 and 37 hundredths. Let's go 2 more positions out. So I'm going to add a 5 in the thousandths column and a 9 in the 10,000ths column. This would now be pronounced as 45 and 3,759 10,000ths. And that's actually how we would convert that to fractional form or mixed number form. 45 and 3,759 10,000ths. We can put 10,000 in the denominator. So that right off the bat kind of explains how we can convert a decimal into fractional form. We would then start talking about whether we could reduce the fractional part after that. Let's say we want to convert a fraction into a decimal. Let's say we have 5/8 that needs to be written in decimal form. Well, if you don't have some of your basic fractions memorized, you're going to have to do long division. And so we would take our 5, divide by 8. 8 does not go into 5. We're going to put a decimal after that 5 and move that decimal up straight through the division bar. And we're going to put a few zeros in here. We don't know how many zeros we're going to need. 8 does not go into 5, so we're going to put a 0 up at the top to signify that the answer is no, it does not go in. 8 does go into 50 6 times. 6 times 8 is 48. So we would then subtract that 48 and get 2. We would then bring down this next 0. 8 goes into 20 2 times, and that 2 at the top times the 8 on the side makes 16. Subtract and get 4, bring down our next 0. 8 goes into 40 5 times exactly. 8 times 5 is 40, and we have no remainder when we subtract. So our answer, or the decimal form of 5/8, is 0.625. Now, we tend to, in American society today, not write that 0 there. That is bad manners. An English teacher would not let you write the word ain't in an essay. And here in math, we do not want a number to start with a decimal. We want to have that 0 there, even if it's just a placeholder, for how we write numbers in decimal form. Now let's talk about comparing decimals. When you are comparing decimals, it's almost like alphabetization, where you look at each digit one at a time. Both of these have a 4 to the left of the decimal, so they're the same so far. In the tenths column, both of these have 3, and the 2 is in the hundredths column. Anytime you have a trailing 0 off to the right, it is of no use, and we can get rid of it. So in this case, these two expressions are equal. We are not comparing 32 with 320. We're just going position by position by position and making a comparison. Let's say we have 5.10 and 5.09. We start with the 5 and say, they're both have the whole number 5 to begin with. And after the 5, we're comparing the 1 versus the 0. 0 is smaller, and so we would have the inequality pointing, so to speak, towards the smaller number. 5.10, in which case we don't even have to have that 0 there. It's an insignificant 0. 5.1 is greater than 5.09. So it is a position by position comparison. We do not look at 10 and 9, 32 and 320 when we're making these comparisons.